Good evening everyone. Now tonight we're just going to do an iPhone 4, which is something we don't come across too often anymore, but they're certainly still used around here, and maybe one every couple of weeks I have one come in. This iPhone 4, we need to do a battery connector for. It's not an uncommon fault with this model. Just with the age, they do tend to, after a few too many cycles off that battery connector, it lifts off and takes with it the pads quite often. So, got ourselves a replacement. We'll get that fit on, and here we go. Alright, let's have a look. Let's get our microscope into a better position, including myself. Let's check our focus. Okay. Aside from the fact that it's got a bit of dust, which is perfectly normal for a phone this age, you can see we've got our ground here. This is a positive. Yes, I'm pretty sure it's that way. Fairly sure it's that way. But the problem we've got here is these two pads have gone for a walk. Now they do connect up to here and here, and they also connect behind this shield barrier. You can see a couple of pairs there, here. So they do go to those points as well. Yep, noisy traffic, standard life around here. So we'll be connecting these up to here. It's going to be a little bit tricky because of the distances involved, but hopefully not too bad now that we've got micro soldering gear. Last time I did one of these, I just had my standard equipment and no microscope, and I still managed to do it. But then again, my eyes were a little bit younger then, not that much younger, just a little. Okay, just clean this up. We probably won't even need to use the hot air for this. Just trying to think whether we'd be better off. I think maybe we'll put the couple of traces down before we put the connector in. May make it a little easier for us. Now, what is this, a little piece of trash? Or we've got a bit of a nub there. Now that concerns me because if that means that the trace is actually going under into there, then reconnecting it to this test point will not do us any good. So we need to check that. And if we do have a broken trace point there, that's going to be fun. Alright. Now, as far as I'm pretty sure it's this one here goes to the top pair and this one to the bottom pair. So let's have a look. Let's first see what that is. There's no connection there to there. So this one should be one of these inner pairs. Okay, is that one? Oh, that's going to be fun. So basically that's useless. We need that. Well, we can run the trace into here. Fun. Now this one here is, I think that's it there. Yeah, never easy, is it? I could try and cut back and see if I can then run from there to there as some sort of a brace wire, a high tension wire sort of thing, and then put the pad over that, because it'd be nice not to have to route it through here. So let's see if I can cut back into there, see what we can reveal. Yeah, I was worried about this. I haven't normally had to deal with a full pad pull off like that on both of them. So this is obviously ground plane. We don't want to be running into that, and that's gone. Okay, are you a veer that goes into there? Okay, you're a little teeny tiny veer there, but where are you on here? Oh, I think I'm gonna have to just run this one. Now these are just signal wires. Ah, crikey. Let's say this is... Yep. Not that it matters about that. No, I wonder where that one did go in. Looks like that's clean gone. Well, that being the case, we'll have to run our wire up and around. Oh, what a posterior pain. Alright, let's get these other pads cleaned up before I yabble on too much. It's a bit of flux to ease the process. Boom, boom, boom. Because obviously that'll be all unleaded. Thank you. Because these are power planes, they do have a fair bit of thermal capacity. Absorption capacity, rather. Okay, they're just holding pads. So as I understand, they're not connected to anything. Okay. Get ourselves a little bit of wick. I should have known better. As soon as I saw them ripped off, I should have gone, hey, that's going to go to the underside. Oh well. Whoops. I almost pulled that off a little bit too soon then. Getting impatient. Yeah, definitely. Yeah, that's curious. See, none of those traces there are coming up into the pad. Let's see if I can get some more light in here and without getting the highlights too much. Okay. You can see all these data lines for you, and that one could almost be less strange. Maybe that one is alright and we can get away with that. But this one, definitely you can see the little nub there. See the nub and the veer, and goes off to wherever, probably tucks in under there. Definitely gonna, but this one here might, but that doesn't, yeah, it might be that trace there, so we'll have to check that out. I could probably look at ZXW, it might have a X-ray view of it. Okay. I'm just going to check that now because that'll save me a bit of grief. This pad here. And this is a bit awkward under the microscope. And we do have continuity. It's interesting why that didn't beep before. Let's just double check that. And hopefully we weren't just freakishly touching something. No. Oh, there we go. We're lucky. Alright. So what we can do is we'll try and scratch down to this, expose that veer that's in there, and bring it up. And this one here we can just put straight across. Ah, the fun and games. That's probably they'll be buried under a layer of fiberglass, so maybe I Should take it a bit. Let's see if we can actually put a solid blob on that. I know, chopping and changing, change my mind. It's just going to be so weak to get on there. So weak. Oh, here we go. Okay, I'm just going to focus on the top half rather than exposing the stuff that's a bit close to... There we go. Rather than exposing the stuff that's a little bit close to the ground plane. I will be covering this with UV mask. Okay, let's clear off a little bit more than that. And my bent tweezers. Now I better hope that isn't actually going through that bit. What I mean is, I hope that there is actually continuity there. So which one was it? Was this one here? What about the outside one? Oh dear. Have we ground it into something that's not actually part of that? Sure look like it. But maybe it's not. Okay, we're at maximum zoom. I mean, I know there's some fine tolerances in circuit boards, but this would be perhaps a little finer than I'd expect. I have a horrible feeling that it actually is just it's going through it. It's not actually to it. That'd be just downright annoying. Times like this, you want ultra fine tips. Yeah, still not convinced. The trouble is my tips are, even though they're fine tips, they're a little bit thick for determining whether that is part of the same veer. So I need to get some clearance here. That's what I'm trying to do for the tip. All this just for the tip. Ah, crikey, now we're exposing something else. Okay. Okay, I'm definitely not touching that middle core. Yeah, you are not. Okay, maybe you are. Fuck. Alright, time to file down my tips. I mean, to me it makes sense that it would be, because it's going into the lower layer, and then it should head off. Like I said, I don't want to make too much of an assumption. Forgive me, tip, for what I'm about to do. Hopefully that's fine enough. Let's try that again. So, got this one here. And now with our little superfine tip. Okay, we're cleared. That's good. Now we can actually solder that up. And the iron's ready to go. That should be enough of a nub. Alright, now the next thing is we need to put down some wire. I have a feeling though this 40 gauge wire, this 0.02 stuff may be a little bit too fine. Maybe better off, yeah, I'm pretty sure that's going to be just a little bit too fine. It's great if you're doing long screw damage or something like that, but probably a bit too much for this. For this sort of thing, we simply want to get some normal wire, take the strands out of it. Alright, so we use this kind of stuff. See, it's got a decent thickness, but it's still pliable. Best thing about this sort of wire is that it's already tinned for us. This is probably akin to MacBook battery wire that Mr. Rossman uses a lot of. Alright, so we're going to tin up those two pads. Yeah, so much for this being a quick job. Yeah, that didn't work out for you, Paul, did it? Come on. Great, so we've got one looking like a dome, one looking like a nipple. Marvellous. I'm gonna admit I actually prefer the dome one. In this case, there we go. That's more realistic. We'll take a little strand. I think we'll turn that one around. Okay, wasn't expecting that sort of damage on that. It looks acceptable. Probably could do with a little more solder. Here we go, this is going to be the don't go for the perfection, but no, we're going to mess with it. Just want a little more solder on there. So what I'm going to do is put a tiny drop of solder paste. It's going to ease you. Does that look like a tiny drop on the end of the it still looks like, and yet it's a massive bulbous thing there. It's like, wow, that's going to short half the board out. Now, theoretically, when we hit that with the iron, it's not even connected again. Okay, so we've got some free range balls here. Let's try and pick them up. They're not interested in being picked up. We'll just use a soldering iron to collect them, gather them up. There we go. Nice and easy. Alright. Now what I might do at this point, we'll cut this off. I'm going to have to put the green goo in. Check that we have continuity as well. No point doing any of this if we don't. Alright, which one were you? You're the inner one. This one here. Very good. Wow, check out how janky that is. So we're going to double this up on itself. So around about there. Cut about there. Making sure not to cut through the circuit board. Lest we go through to the other side and actually catch ourselves a trace. I don't think we did that time. I'm pretty sure that's just, yep, that's all good. That little bit of copper there needs to come out. Gotcha. Okay, let's get this flat to the ground. That's pretty damn ugly. But it'll do the trick. Alright, we've got a connector in here somewhere. Let's have a look at how this sits. Don't need that bit of hair, it's not required. Alright, so we're gonna, this is gonna be a slight problem. Not too bad, but it is gonna result in, so it's sitting up a little proud. I can feel it sitting fractionally proud. Pull that back. There we go, there. Oh, that's great. Just noticed something. This connector is missing. That's no good. I'll have to check another one. Marvellous. You order these parts and you don't really realise until you go to use them if they're dodgy. iPhone parts. Fortunately, I do usually keep more than one on hand. 4S, 4S, 4S. No, 4S is no good to us. Let's see, does this one have the... You're kidding me, you also don't have... What's going on there? What about you? You additionally do not have one. Oh, this is just marvellous. Alright, all my connectors do not have that. And yet, if I look at my 4S ones... look at that, they've got them both. That's going to lead to fun because you really need that pad there to hold it down. Yeah, lots of fun. So I'll probably get away with not green gooing it, but I would rather green goo this. That doesn't seem like proper green goo. It seems like it's a bit diluted there. That seems better. That's not right. It wasn't dry enough. Grigoo is just dissolving, well not dissolving, but it's been diluted into solution. Whatever it is that's there. Ah, geez, Paul, be careful. Right, let's try that again. Still doesn't feel right. Maybe it's just the sheer size that's the issue. I'm used to dealing with, well, most of us, when you're pulling out green goo, it's usually on BGA pads. Maybe it's just the massive size difference which gives the effect of it being less viscous. And because you think it's less viscous, you think it's not right, but it's actually a scale effect. And now anyway, ultraviolet light. Oh, we actually have some flux on that one. Normally this paste is dried out a bit. Somewhat intentional. Helps with BGA reballing. Okay. Just might clean that up a bit. Maybe that these were done using infrared reflow. Just gonna push you back a little bit. Even still. Alrighty, here we go. Well, that one's actually fucking pointless. I don't know why the hell I did that. Oh well. Oh, screw you, Paul. Too busy trying to push down and not looking where I was going. It's better. I had that nice on the first pass and I just botched it up. That's really not good. Now, one thing I have noticed is you gotta heatsink these pins, otherwise they just love to melt through. you're not happening. I think I'm going to need an external on that one. Crud. Jeez, talk about pain in the past. Where the hell did all my solder paste go for this one? I'm gonna put a blob down for you. Yeah, I'm starting to get irritated with this. Yeah, I'm not talking much at the moment because I'm focusing. So here's the trouble. This is a good viewing angle to get the soldering in, but the tweezers don't want to play ball that angle. I'm a little concerned because I can't see any solder up there. Okay, let's add a little bit more paste down there. That's a metric ton of paste. That'll do. Same for you. So it's not a problem. The excess will tend to get pulled back up. Just need to get my fingers in the right because you don't want to pull these pins while they're hot. They'll just deform the plastic. It's not like it. Alright, a little more convinced that's alright. So look, pins are all looking tolerably okay. What have we got going on in there? A little hard to tell with me shaking around. Let's try drop down to non-shake. Okay, well that's obviously bonded and that's bonded, but we do have a bunch of solder balls going on through there. See all this? So we need to deal with those, get them flushed out. individually they're not going to really cause trouble, but they may cluster together and cause issues. But the important thing is we've got our connection between the wire and the pin, wire and pin, so that's good. You're looking a little beaten up there, but you're connected, you're convincingly connected. You were a problem I need to read. And you, well, that was just dumb of me to put that there. Who does that? Clearly I did. Okay. Let's have another shot at that anchor pin. This one here, use a bit of flux. Try to see we've got some balls still hanging out there. And it's not good to have your balls hanging out like that. Let's see if we can, come on. That's better. And this one here, well, that was just plain dumb. And we're going to have to use hot glue or something. But see if we can just reflow this back in. Yeah, they're not inclined to come out, are they? It's like, yeah, this is a $10 job. Why not? But of course, to be fair, a lot of this is my own doing. I got a fair bit of that out. Drop some flux. Try again. Okay, that time I think it worked. Managed to pull it out. What a pain. What a nuisance. What a drama. I'm really just trying to dig out any solder balls that are hanging around. Give it a good flush out. I suppose now we should test to see whether we've got the continuity. So, do you believe it was this one, was it? And this one? No? Yep, that's good. And this one down here, and this one. Well, very good. At least we achieved that. Hallelujah. Now I do have the problem of what is the best solution for here, because see, this is lifting up too much, and sooner or later it's going to rip off that pad again. It doesn't even hold on my holder very well. Now you could wick some hot glue on, not hot glue, super glue under there. That would probably be a good option. I suppose we should really test this at this point. Now what we're going to do, 4G, we're going to set a very low current limit on this one. To a mere 20 milliamp, oh, 30 milliamp. The reason being is, if anything goes wrong, I just wanted to let it snow straight up. I suppose really it'd be more prudent to check the diode mode between these terminals. Okay, that's good. Oh, there we go, 0.4, that's fine. Let's have a look what about you guys. Let's put to positives, 0.4, to first 0.52, 0.58, that looks pretty good. Okay, 4G. These connectors are so bad. Please, for the love of Almighty, tell me that I actually put a 4G connector on there, not something like a... Yeah, cheap, nasty octopus connectors. Okay, on, and we're drawing 12, so we're good. Okay. Let's put this into a test chassis. This is a pretty beaten up chassis, but should do the job. Assuming it's not a faulty chassis. Alright, we don't need the USB, but we'll plug that in anyway. And a battery. Well, at least that fits properly, so there you go. Definitely proof that the other one was crap. The one on the octopus lead. And there we are. Excellent. So we'll wait for that to boot. Being a 4G, it does take a long time. Okay, we've got a 20% low battery. Let's plug it in and see if we get a charge. We don't. What happened there? We had an instant reboot. That's a bit of a concern. Did our battery pop out? Our battery popped out. That was a bit silly. Connector feels fine. I just think I think that second clip that we're missing is needed. Fortunately, we're right next to the screw hole, so we'll probably be able to get away with that. And this is only for testing. Slight concern is that I'm only charging 89 there. 90 could be very low. Let's see. Yeah. I pressed the wrong button. Well, our charge rate sucks. So I'm not sure what's going on there. Do a bad battery. Oh, that's really bad charge rate. As life would dictate, we do not have a spare battery. Typical. Yeah, that's really bad. That's not even charging. Crap. What's going on here? I've got a bad dock cable, maybe? I need another damn battery to compare. How the hell am I going to find an iPhone 4 battery on Christmas Eve? Hey everyone, I just wanted to follow up on the iPhone 4 battery connector replacement that we did the other day, because I know that one of the more frustrating things on YouTube videos can be is if you go through 90% of the process and then you don't see the ending. You're left high and dry and you're assuming things. So it turns out I'm pretty sure that the battery was at fault. And to confirm that, I didn't have any other spare batteries. I only had iPhone 4S, and there's no other 4 batteries around here. I checked my surplus supplies, my junk truck boxes, nothing in them. So I knew that the iPhone 4S was a similar enough battery, and but the connector's a little bit narrower than what the 4 is. So I thought, oh well, I'll just make a swap over. So that's what I did. So I took my original iPhone 4 battery, which we can tell it is because it's only got the one little screw hole there, and we hot aired off the connector. I did that at about 330 centigrade, and they come off pretty quick without damaging the plastic. Now I did the same then to a working 4S pack. You can see we've got the 2 connectors here, and so you can see the 4S connector here. So they're quite similar, the 4 and the 4S, but the 4S is slightly more compact. Yeah, so I took it off, did a really quick hack job of the tinning, and looks like we've got some junk there because it's been floating around on my desk. Now you'll notice the retention pins do not match up. And so you can see here they're a little bit too wide for that top plate, but that's okay. We didn't really care in this situation. What mattered is that our contacts were sitting in. And then, so with that soldered on, it's not going to fit very politely on there. It's going to be a little bit weird. See, it's not perfect, but it does the job. It sits in. It does slip out pretty quickly. I think a lot of that slip out is due to the missing pin on the circuit board. And now, plug in my charger. Just wait for that to boot. So you can see it's holding 89 at the moment. That should pick up. Now we're charging. So in the end it was just a dud iPhone 4 battery assembly, and we're back to normal. We're charging up. So I'm curious to have a look inside this iPhone 4 battery and see if we can see why it decided to be a dud. Okay, so let's start the process of pulling this thing apart. You want to be a little bit careful. You don't want to short out anything. I probably should have considered checking this before I even swap the batteries out, but okay. So we go. So for whatever reason, it doesn't want to accept charge, or it's not talking properly. It will charge if we just directly charge it. Like if I put current on these, it will charge. Or if I power it directly through. Oh, look at that. We've got. That's not connected. That's not connected. That'll be deliberate. It's not a botch job. That chap there looks a little hurt. I'm really unsure as to what to expect there. Looks like that just goes straight to the battery. So there's some sort of high frequency decoupling probably. This white junk that you can see is probably superglue vapor. Yeah, it's just... Okay, so there's no real obvious reason why this wouldn't be working. And I mean, these obviously aren't original Apple boards. There's not a lot of parts on there, so yeah, maybe one of these just isn't quite right, or for all we know, yeah, it's just, we don't know anything here. You look a little mashed up, actually. In fact, there we go. There's our fault. We've got a very broken resistor there. And we've got no real way of knowing what that value was. It's a seriously broken resistor. That would have broke. You can see how this Captain tape is torn away there. So I'd say, yes, that's happened during manufacturing. That's real nice. Good breakage. Let's see, what is that even talking to? For all we know, that could just be it's either something like a 100k pull-up, or it's 0 ohm sort of... I can't imagine they'd waste money on a 0 ohm there. So what does that even connect to? Let's pull out the multimeter and have a look. So this is negative, ground, whatever you want to call it. And we've got nothing there. And we've got nothing there. Okay, so that's some sort of signal line. So let's zoom out a bit and see which one it is. We got continuity mode. It's a little bit risky doing continuity mode because we do have power going through here. Let's try our luck. Okay, so that there goes to that pin there. And that pin, I gotta admit, I'm not sure which one that is. I'm not sure if that's temperature. Either way, we know that's a sensor pin. So the question is, now what? What were you, little fellow? So let me find out what line that is. So that there is the one next to the screw hole. So let's have a look. Bring up ZXW and see what we can find. Pretty sure that pin there is actually for temperature, in which case it could be as simple as just a some sort of 1K or 10K resistor to ground. It's a little bit tricky to tell. What we'll do is we'll measure voltage, make sure we've got our orientations right. So I have a suspicion that there should be ground and that should be positive, and that is confirmed. We have no voltage there. So that, like I said, could be anything, anything at all. We don't know what the... Okay, let's do a continuity check again. Okay, so that, I suspect, might go straight to ground. So let's have a look. It does. So all we have is a simple resistor here. It goes to ground. So we can try... I said we can try a 10K maybe. Let's try put a 10K on there and see if this responds again. The downside is that we have to put our 4S connector back on. Give it a bit of flux to make it easier. Make sure you don't touch the contacts. It can be awfully easy to just short out things. Okay, we need to put some leaded solder onto these. And we've got to do it individually. These here we should probably wick out so that our connector will sit in properly. Yeah, remember, don't touch the other pads. With flux. Well, ideally that should just float back into place. Well, we're just sitting on 320, 330 here. We don't need a lot of heat. We just want to get to reflow and sit. Notice how the plastic didn't melt. That's what we wanted. And those pins are now lined up properly. We'll give that a bit of a wash. That should be good to go. Alright, now we've got to put a resistor in there. So I'm thinking it's going to be, we can start out for 10k. Looks like they're 0402 size, but that's okay. We can easily get away with 0603. It'll fit on those pads. Just need to wick off a tiny bit. There we go. Oh, those tweezers are terrible. Okay, we just got to put solder on the other side now. You'll notice I dragged the resistor across the pad quite a distance, and that was deliberate so that I could get to this other side like that. I needed some exposed pad to be able to bond it to. Alright, in theory, this battery might work now. Might. Okay, we've got a bit of a mess on the desk. Let's give it a bit of a quick clean up. Not too much. Okay, so this is our supposedly repaired iPhone 4S battery, 4 battery. Yeah, I might just try another thing. What do we got? We got this one here. Okay, so clipped in. Now I don't need to look at the screen to be able to determine if this is going to work or not, because this was faulty in the past. So if I plug this in and it starts charging, we know we've fixed the fault. And looks like we've got a charge. Sitting there at 490, seems about right. What is interesting, we don't have a turn on. Okay, we've got a low battery indicator there. So let's leave that there for a little bit and come back and see what happens. Oh, it looks like I walked in at about the right time. Interesting. Let's see now. We're booting. I'm sitting on 84. And we've cleared through. Now we're back up to 716. It should pop up. There we go. There's the buzz. It'll be interesting to see what the phone thinks of the battery. Alright. Well, we know that's working, so that was a pretty lucky guess. Mostly what I was hoping is that I'm guessing that was a temperature dependent resistor, and there's many different center values you can get for that. anything from like 1k up to 100k, and from there then the resistance varies according to the temperature. About 10k is sort of a bit of a middle of the ballpark type selection, so we got lucky. It seems to be working. That generally is, well, I would say it's not guaranteed to work on all the other batteries, but it's worth a shot. The other common one may be, say, 47k, and give it a whirl if you're running into that sort of mischief. But there you go. So we found the problem with the original battery, broken resistor on it, which explains why it was charging before when we just directly powered it, but would not work properly through the iPhone. So I'm glad to finally put a close to the end of that mystery. Okay, well, we'll leave it at that, and thank you all for watching, and until next time.